Odyssey channel, good and interesting science. Dear friends, the search for extraterrestrial life has always been an extremely challenging task for scientists. Many scientists believe that if extraterrestrial life exists, its evolution could occur independently in many different places in the universe. There is also a hypothesis that extraterrestrial life may have initially originated from Earth, then they were scattered everywhere in the universe. In the previous episode's video on the search for life on exoplanet, we have explored the 4 candidates with ideal conditions for life. And today, we will continue to explore and find out, where are the next nominated exoplanets, and do these exoplanets have suitable conditions for life to develop? All of those questions will be explained in today's video. Hope you enjoy watching the video. Don't forget to subscribe to the Odyssey channel and turn on the bell for all. Now, let's go explore together. Please subscribe to the Guy and Migo channel so you don't miss any exciting videos. According to cosmology, all life on Earth is based on the element carbon and uses water as a solvent. In that environment, biochemical processes occur that allow life to develop. However, we cannot impose that extraterrestrial life forms must have such an environment. They may have a different base element and may also use solvents other than water. That is the inference of scientists. But most of them agree that those life forms must certainly have a place to reside, none other than exoplanets. Now let's explore which exoplanets are next nominated as potentially capable of supporting life. GUD 1061c is an exoplanet orbiting within the habitable zone of the red dwarf star, Mount 1061. This is a star located about 14 light-years from Earth. Therefore, planet GUD 1061c becomes one of the exoplanets with the most ideal conditions for life closest to Earth. Therefore, it has garnered considerable attention from scientists. According to records, this is a rocky planet classified as a super-Earth. It has a radius about 1.6 times that of Earth, and in terms of mass, it is about 4.3 times the mass of Earth. The special thing is that its orbit lies within a habitable zone of its host star. According to scientists, the exoplanet Red Needle GUD 1061 has a brightness equivalent to only 1% of the Sun's brightness. Therefore, they determined the habitable zone of this protostar to be within a range of 0.073 to 0.19 astronomical units. Planets within this region, if they have a suitable atmosphere, could potentially harbor liquid water, creating favorable conditions for life to develop on exoplanets. The distance from planet GUD 1061c to its host star is 0.084 AU, or about 12.6 million kilometers, which is much closer than Mercury's distance from the Sun, the planet closest to the Sun in the solar system. At this distance, planet GUD 1061c takes 17.9 Earth days to complete one orbit. This means 1 year on planet GUD 1061c is equivalent to 17.9 days on Earth. With such a relatively fast cycle, if humans could set foot on this planet to live, our lifespan might even be calculated to be up to 1,000 years old. Because the planet has an orbit quite close to its host star, it may be tidally locked to the star. It means one side of the planet is always illuminated by its host star, while the other side remains in perpetual dark. This leads to extreme temperature differences on the two sides. With one side continuously illuminated by the star, its temperature is quite high, while the other side, shrouded in darkness, is extremely. It is estimated that the planet's equilibrium temperature is about 223 degrees Celsius, or roughly minus 50 degrees Celsius. At this temperature, it is slightly higher than the equilibrium temperature of Mars. Life is expected to exist on this exoplanet, likely in the terminator region between day and night. It lies between the illuminated side and the non-illuminated side. Then if the planet has a suitable atmosphere, water could exist in liquid form in this region. And that could be favorable conditions for life to form and develop. But because the exoplanet is about 14 light-years from Earth, with current science, it is very difficult for us to observe and analyze the living environment on exoplanets in detail. Therefore, all analysis is merely prediction, hoping that in the future when science and technology, we can observe and analyze this exoplanet in more detail. Kepler 1229b is also known as planet COI 2418.01. This is also a rocky planet classified as a super-Earth. Exoplanets have orbits located within the habitable zone of the star Urantia. It was first discovered by the Kepler Space Telescope on May 12, 2016. According to calculations, Kepler 1229b has a mass approximately 2.7 times that of Earth. As for its size, it has a radius approximately 1.4 times that of Earth. It is located 0.2960 from its host star, equivalent to 44 billion whole. At this distance, the exoplanet takes about 86.8 Earth days to complete one orbital cycle. With this orbital period, it is equivalent to the orbital period of Mercury, the planet with the fastest orbit around the Sun. Scientists believe that Kepler 1229b may also be tidally locked to its host star. One side of the planet is more illuminated by the host star. The other side lies in eternal darkness. Therefore, we can only hope that life exists in the border region between the bright day side and the dark side of the planet. But when scientists measured the distance, this exoplanet was very far from Earth. According to estimates, it is about 870 light-years away from us. Therefore, we cannot yet know whether this exoplanet has an atmosphere or not, based on the distance to the host star and the star's brightness. Scientists believe that the equilibrium temperature on Kepler 1229b is only about 213 Kelvin, which is minus 60 degrees Celsius. But of the border area between the dark side and the light side, its temperature can reach 273 degrees Kelvin, which is 0 degrees Celsius. With this temperature, if the exoplanet has a sufficiently big then perhaps it qualifies to support life. At that time, water could exist in a liquid state in this area. As for the host star Kepler 1229, it is a red dwarf located in the constellation Cygnus. From Earth, it has an apparent magnitude of 14.47, which is too faint to be observed with the naked eye. According to calculations, this is a relatively small star with a radius only equivalent to 51% of the Sun's radius. Additionally, the surface temperature of the star is only about 3784 Kelvin, which is considerably lower than the surface temperature of the star. Therefore, the measured brightness of the star is only 4.8% of the Sun's brightness. Therefore, although the planet Kepler 1229b has an orbit quite close to its host star, it still lies within the star's habitable zone. One interesting thing about red dwarf stars is that due to their small size and low luminosity, they can exist for much longer compared to the Sun. Scientists estimate that the red dwarf star Kepler 1229 can be between 50 and 60 billion years old, roughly 5 to 6 times the lifespan of the Sun. Cap 10b is a planet located about 12.8 light-years from Earth. It is also a planet located within the habitable zone of a red dwarf star. This planet was first discovered using the radial velocity method in June 2014. It is also categorized as a super-Earth, with a mass approximately 4.8 times that of Earth and a radius about 1.6 times larger. Because the host star has only about 28% of the Sun's mass and size, its luminosity is only about 1.2% that of the Sun. With stars like these, scientists predict they will have a lifespan of approximately 100 to 200 billion years, about 10 to 20 times the predicted age of the Sun. From the initial analysis, planet Cap 10b is located at a distance of 0.1680 from its host star, which is equivalent to 25.2 million kilometers. At this distance, the planet takes 48.6 Earth days to complete one orbit, which means 1 year on Cap 10b is equivalent to 48.6 Earth days. It is estimated that the planet's equilibrium temperature is around minus 68 degrees Celsius, which is likely too cold for water to exist in liquid form. But if a planet has a suitable atmosphere, if there is enough CO2, when the greenhouse effect occurs, it will keep the planet warm. And then, water could exist in liquid form on the surface. For common occurrence such as planets orbiting very close to their host star, scientists predict that Cap 10b could also be highly locked. Therefore, life on this planet can only be hoped to exist in the border region between the illuminated side and the non-illuminated side of the planet. At a distance of 12.8 light-years, while considered close in cosmic terms, it remains a significant challenge for human science. We still seem to face many difficulties in observing and analyzing an exoplanet at such a distance. Kepler 186f is an exoplanet orbiting a red dwarf star, located 580 light-years. It was discovered by NASA's Kepler Space Telescope on April 17, 2014. Shortly after its discovery, this exoplanet received considerable attention from scientists. They calculated that Kepler 186f orbits its host star at a distance of 0.432 astronomical units, slightly farther than Mercury's distance from. At this distance, the planet takes 130 days to complete one orbital cycle. Additionally, this region lies within the habitable zone of the host star. Being on the planet can support liquid water given a suitable atmosphere. However, because it is located very far from Earth, 580 light-years away, we still have no information about the planet's atmosphere. In June 2018, scientists used the 10-bar linkage dynamic simulation system for exoplanets. The results show the planet's tilt and how that process evolved over time. This axial tilt will contribute to the creation of climatic seasons as the rays from the host star strike the planet's surface, similar to sunlight shining on the surface of the Earth. Therefore, this exoplanet is one of the exoplanets that gives scientists hope for the existence of life on it. Compared to Earth, Kepler 186f has many quite similar characteristics. Its radius is approximately 1.17 times. That means the size of this exoplanet is just a little larger than our Earth. Additionally, with an orbital period of about 130 days, the chance of Kepler 186f being tidally locked is about 50. This exoplanet has a 50% chance of not being tidally locked to its host star. If this happens, Kepler 186f can be considered an Earth 2.0. Continuing at position 9, planet Kepler 62f. Kepler 62f is a super-Earth, orbiting a K-type main sequence star. It is confirmed to be located within a habitable zone of its host star. According to scientists, this exoplanet is located at a distance of 0.7180 from its host star, equivalent to 71% of the distance from Earth to the Sun. At this distance, the planet takes 267.3 Earth days to complete one orbital cycle. This means 1 year on Kepler 62f is equivalent to 267.3 Earth days. Additionally, the exoplanet could receive an amount of light equivalent to 41% of the light Earth receives from the Sun. By using research models, scientists believe that the planet Kepler 62f could be entirely covered by ocean. Additionally, this planet is one of the rare planets located in the habitable zone of a star that is capable of hosting moons, meaning its distance is suitable for it to have a natural moon. Therefore, this can be considered a strong candidate for extraterrestrial life. At its distance, it can avoid dangerous radiation bursts from the host star. On the other hand, Kepler 62f has an orbital period of 267.3 Earth days, making it stable enough to potentially support life on the planet. However, there is one thing. If its atmosphere is not replenished with greenhouse gases, and perhaps from here on out, it would be covered by vast, icy oceans. Another plus point of planet Kepler 62f is the host star it orbits around. This is an orange star with a spectral type of Ca. Stars in this spectral class produce relatively benign radiation and also have a fairly long lifespan. Therefore, scientists are even more hopeful for life to emerge on Kepler 62f. Compared to Earth, Kepler 62f has a radius approximately 1.4 times that of Earth. With this size, the planet has ideal conditions for the development of life. You have to worry about the story of cramped land and dense population life on Earth. But when it comes to calculating the distance, it produced a disappointment for the scientists. Because this exoplanet is about 990 light-years away from us, the distance too far for humanity to dream of visiting in the future. Planet Lead 10b. Planet Lead 10b, also known as GY276b. This is a rocky exoplanet also located in the habitable zone of a red dwarf star. It is also dubbed by scientists as one of the most Earth-like exoplanets ever discovered. First discovered in March 2017, Lead 10b is known to be a super-Earth, with a radius approximately 1.35 times that of Earth. Located at a distance of 0.1002 astronomical units, this exoplanet receives 6% more light from its host star than Earth receives from the Sun. This is precisely what makes Lead 10b a promising candidate for planets with ideal conditions for life. At this distance, Lead 10b takes approximately 18.6 Earth days to complete one orbital cycle. This means 1 year on Lead 10b is equivalent to 18.6 Earth days. Unlike many other potentially habitable exoplanets orbiting red dwarf stars, Lead 10b has the advantage of orbiting a very quiet host. The orbit of Lead 10b has a very long period, 118 days, and it does not easily experience strong radiation burst phenomena like ordinary satellites. Therefore, if Lead 10b has an atmosphere, and at a distance that is very close to its host star, however, it can maintain that atmosphere for billions of years. For these reasons, scientists believe life could exist on Lead 10b. When calculating the distance, scientists were delighted to discover Lead 10b is quite close to Earth. It is only about 12.2 light-years away from us. Therefore, in October 2017 and 2018, the METI organization sent a message to the exoplanet Lead 10b. This message included dozens of short musical pieces. They hope that when the message reaches Lead 10b, we will receive a response from the civilization there. It may take a very long time for the message to reach Lead 10b and return to Earth. But let's wait together. Perhaps a surprise will happen in the future. Then, we might receive a response from friends 12.2 light-years away. So today, Talk 2V and you have explored the mysteries of exoplanets with ideal conditions for life. Wishing you an enjoyable video viewing. Now, please select the video on the left or right side of the screen to join Talk 2V in decoding other mysteries of the universe. See you in the next videos. Goodbye, everyone.